Well, hi, I'm Doug Cogswell. I'm the president and CEO of Advizor Solutions, and I'm going to spend 35 minutes talking about using data analytics to improve operational efficiency in customer communications. I'm going to go through some high-level concepts, but more importantly, talk through some examples from our clients and how they are using the data that they already have in their financial and factory floor systems to make better and faster decisions. So high level, our premise is you've got a lot of data. It can help you run your business better, but it's hard to get at and often causes a cycle of pain of trying to connect it, export it to Excel, format it, get it into a position where it can actually help you in team decision making. And what we're all about in this talk is making your existing data easy to use so you see stories. Very visual displays can help you identify issues that you can take action with. Data-driven discussions and collaboration. So just at a high level, we're talking about the whole concept called data discovery, and it's different than reporting. The Gartner Group, the Forrester Group, all the people that write on business intelligence technologies like this clearly differentiate these technologies that are aimed at doing different things. Reporting is basically pre-structured formats, primarily static. It's quick, gives you essential facts, it's well formatted, and has standard outputs. Obviously, financials are a great example of a report or a production report, which has stats on what happened yesterday. Data discovery is much more ad hoc, highly interactive. Often you don't know the questions. You want to see the stories in the data. You sense that there's something going on around, turnaround time on your orders, but you're not quite sure what or where or what even question to ask. So by seeing the stories, you start framing these questions. And this is an iterative process, and then you're slicing and dicing, drilling down, really in an ad hoc analytical sandbox with your team to get discussion around, can we improve the throughput here? Should we be charging more for these types of parts and processes? And that's what this is about. So I just wanted to highlight that data discovery is a different set of technology and tools than reporting. I mean, reporting typical would be Microsoft SQL Server, Oracle, those things. This is more, us. Advizor, Tableau can do some of this. There's a company, ClickTech, that does a lot of this. There's a bunch of ad hoc analytics, R, SPSS, SAS. So there's different ways of getting at this, but these are different tool sets than this. So get into it. We talked a bit about the cycle of pain. I'm sure many of you deal with this. You sense that there's something going on with throughput time. So request goes to IT, somebody does something with the database, there's a backlog, it takes a while to get it. You see the data, it begs another question. There's this tough cycle. The other version of the cycle is pain, is downloading extracts from the database into Excel, slicing and dicing, and it's hard to do, time consuming, you're missing data. It's hard to show anybody, and then you end up with a shadow data system because it was hard to get this stuff out. So you don't get it out regularly, every day, twice a day or whatever. So now you have old data you're trying to make decisions on, and you somehow have to refresh it, but you got to go through this cycle again. We're talking about, a much more collaborative process where it's like real time at the speed of thought. So you're clicking, spinning on this stuff, and we'll show you some examples in a minute. So where this type of analytics, this data discovery, makes a huge difference is in order analysis. Customers, orders, processes, parts, throughput time. I'm going to show an example of using this for a customer who's coming in, and you want to show them how things have improved. We're also going to look at some orders and processes and maybe orders that are taking longer to get through, 8 days or more versus typically we're targeting 1 and 2 days. Ops analysis, utilization, efficiency, downtime, quality. We'll look at this a little bit. Revenue analysis, where are we having receivables, invoicing problems, and there's a bunch of custom data analytics. So these are the set of problems that these data discovery analytics tools are best aimed at answering. If you drill in on order analysis, we're going to go into some examples in a minute, but the questions would be, how fast are we turning around orders? What are our days outstanding? Receive to ship date, by customer, by process, by part number. You want to drill through and see, is it a customer issue? Is it a custom part for some customers? Is it a general part with some process problems for all my customers? What you do based on how those questions come out, what the data shows, is very different. Where are we missing required dates? What's causing us to miss dates? What are the trends? Are we getting better or worse? Especially with customers, we'll see an example. Maybe things were getting worse, but you took action. Now they're getting better. You want to show them that. What are the growth trends? So we have good and bad customers. I mean, a good customer is maybe there's bad customers with tough parts that we can't get through the machines efficiently. It takes more loads. It takes more time. So we lose money on them. That's a decision. Do we want to price that up? Maybe not accept those orders? What are the ground rules for that? How can we better communicate improvements? How can we set proper expectations so that they've been met? How can we simplify basic reporting? I mean, you don't want the cycle of pain. You don't want tons of reports. It's easier if you can put this in a format where you can just sort of slice and dice through it. So I'm going to, this is the idea of using, going back one page, data discovery and analytics and order analysis. These are the kinds of questions that generally get answered. I'm going to go through some scenarios now, which is disguised data from clients and just show what people are doing with this. So let's take a look. Here's an example. If an order analysis dashboard, got a couple of pages. We're looking at orders. There's a heat map, visual view, parts, there's an export page, processes, different ways of looking at the data. But high level, we're looking at, it looks like a couple of years here. We had a lot of orders, 144,000, a bunch of customers. The average order time is 3.5 days roughly. Here's my customers over that period. Kwamba gift box, by the way, this is disguised data. These are not real customers. Had a lot of orders. And they went through actually, ahead, 3.25 versus 3.48. I can see I've got some customers that are higher. Here's one, Skyjo is 6 days, so they're running a lot longer. My orders per month have been pretty consistent, good. Average order turnaround time is actually going up. It had been 3 days a couple years ago. It's up around 4. We're going to look at that in a minute. Here's like I want to click. I might get the orders under 5 days, under versus over. Open orders in his order turnaround, I can slice different ways than this. So this is sort of a dashboard where we've taken 144,000 orders over a couple years, and we've put them in a frame where you can quickly look at it. So one question here would be, let's take a look at Hava Game Supercenter. I mean, they're coming in for a visit next week. And we want to see kind of what their performance has been. We've had some challenges and turnaround. We made some improvements. We want to show them what's happened. So they are just high level. Had a lot of orders, a couple 2,700. Turnaround time is pretty good. That's actually really good. Let's look at what's gone on. So I click them, and it drills down. So now I'm just looking at them. Orders by month have grown. It's been flat the last 6 months, but it's generally on an upward trend. Order turnaround. Now, here's what we had discussions with them like a year ago. They were getting some months where it was 4 days, and generally the trend was going up. So had this upward trend with some spikes. They came in and talked to us. We had a meeting. We made some changes. We identified some places where their orders were getting hung up. And now we can show them quite convincingly the average order turnaround time by month has come down. And we're now down, we're running 2 days, 1.7, went up a little last month. This month's still in process, so it's too early to tell. But when our clients use something like this with customers, it's a very convincing story. We heard you, we made some changes, and here's the data. It's getting better. We're continuing to work on it. That's one way of using this. Now let's go back to everybody. So we're back to the whole thing. And what we did down here is we wanted to look at why do we have any orders over 8 days? So, you can sort of see the distribution. 1 to 3 is the biggest number of orders, and then it falls off. But there's a bunch of them. So I took the mouse, I swept over these. There are 800 customers with 16,000 orders with an average order time of 13 days. And these are all the ones over 8 days. And what happens when I selected the bar chart, I see the number of orders that are over 8 days is going up pretty dramatically. I was running 400 a month a couple years ago. I'm up to 900 a month now. That's not a great trend. The order turnaround time on the long orders is consistent, but the problem is there's more of them. So now we want to drill in. I can see over here I got customers that have more of them and whatnot. So let's go to another view. This is the same data, those same orders. This is called a heat map. This is a visual display where we're trying to look under those orders at the processes they go through. And this is from a surface finisher, not a heat treater, but obviously there's a bunch of similarities here. It's a similar kind of process. There's molding. and there's a set of processes in molding. There's painting, a set of processes in painting. Packaging, a set of processes in painting. Quality control goes through, sorting, and then drying. So if you look at this, and I told you that the size of each of these boxes, like packaging bags, that's a big area. That's sized by the number of processes. So there's a lot of action in bags, and it's colored by the average step time. So red is really long, like 18 days, and green is really short. I don't know why it's minus, but pretend that's 0. So if you look at this, and red, big and red is bad, what jumps? Well, one thing is there's a lot of big red stuff in packaging. So I'm visually clued in that it appears I have some problems in packaging, and it's not bags, they're big and green. It's boxing and barrels and small boxes and buckets. All these packaging areas are causing me problems at the process step. So I can take the mouse, this was active, and just click on the dashboard to grab these red things. Then I can go over here and drill down on it. Here's all the parts and the processes and the customers that have orders going through those processes over, and the whole orders are taking over 8 days. And high level, like what do I see? Well, I have a 1x4 plate. There's a lot of them, and it's taken a really long time. I've got some other parts that there's a lot of them, and they're taking some really, really long times. I got different process steps in here. This is what we saw in that heat map view, and then I got a bunch of customers. So let's click one. So I'm worried about this 1x4 plate. I can click here to select it. And what do I see? The 1x4 plate goes through 8 key processes. You can just look at the numbers of steps. The biggest one is the S-Box SD1, 13 days. Some of these that's 1,125. So these ones are by far the biggest, and there's another group, and then there's some smaller ones. And it's many customers. I mean, this is obviously a common part. A lot of my customers have it. I have probably in this case, I would say, let's have a discussion about why is this taking so long, and what can we do to shorten this, because this is not good. A lot of processes, a lot of orders, and it's taking far longer than it should. So this is one where in a team discussion, say in a war room, you want to talk through this and figure out what can we do to fix some of these processes so they go through more efficiently. So we started with the 1x4 plate was the biggest issue, and we have a storyline here we can now work on. Let's go back. Another one. So look here, these things must have some outliers. The orders are going long, but these processes aren't so bad. Here's one though, the brick 1x2x2 with a center pin, 118 processes, a lot less than the 1x4 plate, but it's taken 8 days. So what's going on with that one? So I click that. Wow, different situation. It's this tool sack packaging process that's taken a long time, and it's one customer, Kevin's Inc. So the first one was like across like a lot of my customers, and it was a set of processes. Here's a part with one customer that seems to have a problem with this one process step. So here I would have a choice. I mean, maybe I should charge more for this. Maybe this part is specific to Kevin's Inc. and it's a problem for whatever the reason. We should charge more. Maybe, it's just not a good fit for this process and it should go somewhere else. But we've highlighted the issue with this part that we want to drill on, because fixing this will make us more efficient and get our cycle times down. Let's look at it another way. Mibu Playroom is one of my customers. They had 373 orders at almost 17 days. That's a problem. So I clicked Mibu Playroom. I'm going the other direction. So these lists pivot. When I see that, I see Mibu Playroom. There's a bunch of processes. There's 7 processes which are taking a long time. A lot of volume, these top 3. And then there's some parts. This 1x4 plate we already saw as a common part. Got it. But these road signs and this panel are specific parts to Mibu Playroom. So I've kind of got the same issue as with the situation before. I've got some parts that are challenging me in the packaging area, and I might want to charge more for them, or maybe not do these anymore, or fix the process. Something needs to happen here, because this is causing issues in my turnaround time. And if I want to improve performance, I've drilled into where I know how to do it. That was 3 examples of throughput time, which matters to customers. Starting with an example of a customer, and we did things to make it better. Now we're taking the long orders over 8 days and looking at them from different angles trying to drive discussions based on what the data is telling us for stories, but how we can prove it. And that's what these data discovery tools let you do. And very different. Imagine trying to do this with a reporting tool or Excel. You could do it, but it's a cycle of pain. So these tools are designed to really kill the cycle of pain. So we dove into order analysis. We're now going to look at a couple of examples in operations analysis, and then we'll kind of just talk more generally about revenue analysis and custom stuff you can do. So let's dive in and look at order analysis. Operations analysis, excuse me. So here, the set of questions are different. How efficiently are we using our assets? Downtime, patterns by facility, line, shift, machine operator. So we're going to look at an example. Again, it's a surface finisher, but a heat treater is similar types of processes where you have large machines and loads go through in buckets. So it's buckets or loads is the capacity of the machine. And you care a lot about the price per bucket or the price per load. And that could be high or low because of how we're pricing, or it could be high or low because of how we're running the machine. It might vary by line or shift. So there's a set of dimensions here that are going to help you understand why some loads are going through efficiently and some aren't. Quality. How well are we managing quality? By reject type, by shift, by process. If you have quality issues, that's an issue. That's clearly a problem. What's driving it? And you need to drill in under the data to get at the facts. Are we aligning production to our preset shipping routes? That's another set of things where, is that working well? Are there outliers? And a lot of this data discovery, as we saw in the previous example, is highlighting outliers, like orders over 8 days. A heat map, shows outliers. It shows those packaging processes. They jump at you. You might not know that, but the visual shows you that, so you can drill in and have a discussion. We'll see that on operations in a minute. What should we do to improve our return on our production assets? What's the actual true cost load? So here's where we actually want the data from the machines, the numbers of loads, the time in the machine, all of that stuff. So, and this is the ERP system has a lot of the information if scans are going in and outs from the machines to do the prior order work. Here we're going more into working with not just the ERP system data, but also the factory floor, the machine data. And you'll see in a minute, we're going to go through some data maps on where all this comes from. But here you're getting into actual true cost. You want to know what the actual throughput production efficiency of the machines is, and so forth. What's driving losses? Revenue and receivables, what's driving revenue by customer, by process? Are we quoting effectively? What's our expected cash collections? Are there patterns of delayed receivables? Do we have anomalies and outliers? The same kind of thought process, but obviously the topics and the users are different. Let's dive in and look at a couple of operations examples. So here is one looking at operational efficiency. This demo data, there's a couple of lines, line 1, 2. There's invoices, there's a bunch of other machine ops, order lists. So there's a set of pages that have different views of the data. We're looking at line 1. This scatter plot has price versus number of loads. So this is how many loads, and this is how much revenue we're getting, the vertical axis. So obviously, higher revenue, these outliers up here are priced higher. These ones down here are potential problems. Like this would be an order that's going through at taking a lot of loads, but we're not getting much money for it. And this histogram here shows the distribution of numbers of, this is how many, and this is the price per load. So, our median price per load is $35, $40, but we run way down. Here's some that are under $10. Here's a couple lower. This must be some promos or something at $0. Then we've got some that run way up high, 154. There's a wide range of revenue per load. And we care a lot about this because this is how we pay for our production capacity, high level. There's a heat map, which takes the same data and shows it by customer. So Zava Amusements is big. It's got a lot of loads going through our factory, colored by the average price per load. It's median. So median is in the $35, $40 range. Green is way up at the top. Red, like this one, is down at the low end. So this also helps you jump to see if do I have patterns of customers who have low revenue per load, which I care a lot about. And you've got the data sheet over here of the list of who they are, the price, the number of loads, the price per load is sort of, but here's the one that gets the most, and at the bottom, you scroll, the list is smaller. This is the same thing with the parts. So, you see you've got some parts that are seeming to be problems. Here's the parts, the same data. So I can click on this one, which jumps. What is this thing? So I click it. And what lights up is it says Dubuque Brickworks, and it's got a set of parts. This AA whatever 0630, which is highlighted here in the list, is big and red. There's actually 686 loads have gone through it, 760 a load, which is way below my median of 35 to 40 bucks, which I'm targeting. And it had some other parts that went through over here. You can see the little ones, and they're showing up here. So this visually shows me two things. I have an outlier customer with an outlier part, and I'm clearly not pricing enough for it because it's taken up a lot of machine capacity, but I'm not getting my return, right? So maybe instead of, if this had been pushed, it should be 5 times more, 35 bucks instead of 5,000 bucks, 35. It's 5 times more. That's $25,000. I'm leaving revenue on the table and or hurting my operational efficiency and cost effectiveness. So you can also see the scatter plot here shows the orders for Dubuque Brickwork. Actually, this is the processes running through. And, here's the trend line for everybody. This trend line is way off, and you've got some pieces up here that are just off. So it's showing you the data in different ways. Again, at the point where you can take action to figure out what's going on here. It might be a pricing issue. It might be we're not running the machine right. Like, why is it taking this many loads? That's a discussion, and maybe some ways to make it more efficient. Maybe it should be on another machine, a bigger bucket. I don't know the answers to that, but this at least sets up a bunch of hypotheses to talk through. And then note here, enhance with predictive models. So what I just did in several examples, we would call visual discovery. You're literally looking at the data, we're using shape and size and color to highlight things that are outliers, and then you can click on them and drill into the detail, and the detail is where you take action. But you can also use modeling tools to create flags for those kinds of things. Like if you want to understand the characteristics of orders that are, have low price per load and flag them, you can use predictive modeling to flag, what's happened in the past. You get the factors underneath, you start understanding it. You can score new orders based on their potential to have the same behavior and flag them, and then you could do something about them, before they go in. So there's the predictive modeling enhances the kind of dashboard, visual display, discovery, storytelling, drill downs that I've just been sharing, and once you get that going, it can help set these automatic flags that are more like a report where you're flagging, I think I've got 12 problematic orders that are in the system, not yet signed off on, we want to look at and maybe adjust pricing or think more carefully about how we should load them on the machines. So this is sort of, in our world, after you get the data together, you start understanding the stories, you can start automating and create these models and these flags. So stuff that matters, you just flag and you come in the morning and there it is. I want to take action on these things to get at them before they actually go in. So that was sort of a run through on a data discovery approach that's different than reporting. Ran through some examples in order analysis and operations. Now let's look at what it takes to make it happen. What's behind this? So in that example, and yeah, I like hand drawing stuff, so we hand drew a chart, but there's ERP data coming from IT and finance, visible aspects of this. There's reporting levels on it. So you got finance sales reports, but this is all the details on the orders. And if you're scanning, often this will have, the in and out times and a bunch of data there. On the ops side, this is more invisible data. So people tend to see this. This sits behind the scene. So, your factory control system or your machines have all kinds of data. They have every step the machine's doing, and the operators are scanning things in and out. They're authenticating, they're seeing it, but usually this is sort of behind the scenes. This could be actually keyed and linked to the ERP data. So if you click an order here, you actually see the steps in the factory over here. And if you've got machine sensors as well, they can be brought in. So high level, we're talking about a data discovery and analysis tool. The the analysts are calling these data analytics and integration hubs is another word for this, but they're capable of bringing in the ERP system data, the machine sensor data, the factory floor data, merging it, blending it, synthesizing, so you get those holistic visual views we've just been looking at. And this gets you looking at process time and dwell, kind of bring them together all into one world. There's a lot more underneath this. I'm not going to try to get more technical, but yeah, if any of you have my contact information at the end of this, we love talking about this. We love helping people do this. We've got a bunch of experience in the surface and heat treating arena on doing this to create the kind of benefits we just talked about. We'd love to go further. But this is a model that works. And as I said, there's a number of these data discovery and analysis tools kind of representing the concept generally. And some of the analyst firms, again, like the Gartner Group, the Forrester, Wayne Eckerson, all business intelligence analysts who can give you a spectrum of what the tools out here are that do this kind of stuff. This is a Gartner slide. So whenever you do this work, you start importing raw data. Like at the beginning, you don't quite know what the machine data is going to have and show you, or the sensor data. So you have to explore it. And then you have to transform it. You got to like bin the thing, like how many loads in the last 6 hours. I mean, that's, or a shift or whatever. The machine's data needs to be grouped and bin transformed. Maybe some data has to be blended and merged. You need to bring something over from the ERP system to put identifiers on the factory floor data. And this is like, Gartner calls this data science experiments, where you're playing with it, you're mucking around in it, and it's an iterative process where you improve it, you go back, you explore it some more, you transform it. So you work this process, and there's consulting firms that do this, we do this, and then out of this comes knowledge gained, reusable transformations that then get put into production and can be used every day to answer the kinds of questions we saw earlier. So I guess the point here is, this is not like, you got to do some work to understand the underlying data, but there's a bunch of tools and people that do this all the time, and the kinds of results that you saw earlier and the benefits can clearly come out of this, and it's totally doable. So my last slide here is, you put all this together and then you got to use it. And up on our website, you'll see in a minute, we've got, especially I think we've got SWD, which is a surface treating firm in the Chicago area. Their CEO, Rick DeLauder, believes he's done a great job of this. And we've got a white paper, and we've got actually, I think, him recorded talking about this. So to actually get transformative change off of your data and analytics, senior management needs to believe it will have benefits. In SWD's case, Rick has driven this. It has to be pushed out the team. The ops managers have to have it, have to use it, have to be able to muck around it and understand it. It has to be in a form that they can use it. Rick's done that well. His ops managers use this every day, all the time. The next concept is a war room. So what Rick's done well is he comes into the war room with questions. I wonder why we have a growing number of orders over 8 days. And then the team uses the data often up on a screen, with everybody, with the key people in the room, and they talk about it. And it's like, there's a set of things you'll find. And then, is this a problem? Is this something we don't want to do? Is there some way to fix it? What's the storyline here? So this war room is really important, and asking the right questions based on what you see and cycling back and forth in these open, transformative discussions is the key to taking any tool like this and having it be successful and really improving operations. And then highlight and promote results, because your teams are busy. People don't necessarily say, hey, I want to use an analytics tool. I want to get up and click on a dashboard every morning. No. But if they realize that their peer just improved their cycle time by 1 day, or improved profitability because instead of getting $5,000, they're getting $25,000, so their gross margins went up, and that gets promoted. Hey, I use this thing and it helped me do better. Highlighting and promoting those results is really important because it cycles through this thing. So this becomes a positive, reinforcing experience that people want to do. So I'm going to stay on this for another minute here, because people often underestimate the process, the team communication side of this, right? They invest in a system, they put it in, everybody gets all excited, and then we see this. 2 to 3 months later, nobody's using it. It's shelfware. Why? Was the system bad? No. The team just never used it to have these transformative discussions. Like you got to drill in and get answers out of it. So I can't reiterate strongly enough that creating this culture of analytics and having a process like this is super important. And even, if all you want is more on this, I'm just going to close. You got my contact information, and at manufacturingadvisor.com, we have like a white paper on this. We got Rick talking about it. We love talking about it. We got other clients who like to talk about it. I think it just whole out of this, the process is really important. And on the data, I go back to the beginning, and I argue that everybody's got a lot of data, and it could be used a lot better. And it's getting the right tool, the right way to access blends, synthesize it into useful content so it actually shows stories and helps drive discussions. And that's totally doable. And I encourage you to step into this and take some of these concepts and work with them. So that's my talk. You know how to reach me if you want to follow up. Appreciate the listening ears. Take care.